Hello everyone, welcome back to another lesson on measurement. Today we are going to be investigating an introduction to surface area. Let's look at the concept map together. So guys, we are going to first define what a polyhedron is, then I'm going to actually define what surface area means. Then we are going to look at how I would calculate the surface area of rectangular prisms as well as the surface area of cubes. Let's have a jump into our definitions. So a polyhedron, let's try and say that 10 times really quickly. You'll get a bit tongue-tied. So a polyhedron is a three-dimensional figure with 4 or more flat surfaces. So essentially, guys, this is talking about your 3D shapes. So your pyramids, your cubes. When I'm talking about the flat surfaces, I'm going to ask you to have a look at me, is that I'm talking that there are actual surfaces on the shape. It's not a 2D shape where you have a circle on a piece of paper, because that's flat and that's 2D. I'm talking about an actual 3D shape that actually, if I had a model of it, I could hold it. So I could hold a type of pyramid. I can hold a box of biscuits because that's a rectangular prism. So a polyhedron is essentially a really fancy way to say a three-dimensional shape. Let's go back to the board. So we are able to calculate the surface area of a polyhedron. And the total surface area of a polyhedron can be found by adding together the areas of each face of the polyhedron. So essentially, I have a 3D shape, and I'm going to add the area of each of those faces together. Now, guys, you might be squinting a bit and saying, what do you mean a face of a shape? A face essentially just means a side. So if I'm thinking about a box of biscuits, there will be sides along the rectangular prism, and I would have to calculate the area of each side of the box of biscuits and add them all together for that to be the surface area. So essentially, a face is essentially a side of that object. Let's go to the next slide. So if I wanted to actually find the surface area of a cube, the surface area of a cube can be found using the sum of the areas of 6 squares, keeping in mind that a cube's exterior is made of 6 squares. So we can see over here, there are 6 squares involved. So I've got the top square, which is number 1. I've got the back square, the side square, the other side square, the bottom square, as well as the square that's facing us. So we can actually see that there are 6 individual squares that make up the exterior of a cube. So you can also think about a Rubik's Cube. On the outside, it's made of 6 squares. But if I'm going to be adding the area of 6 squares together, that means I'm going to actually have to write all of those areas out. But what's quite cool about a cube is I know that the lengths are all common. So if I look, for instance, at the top square, we know that the area would be length squared, because area is length times breadth, which would be length times length, which is L squared. That's why it's L squared. If it was a rectangle, we know that it's not the same distance, essentially, but because it is a cube, it's made up of squares, so it's length times length, which is length squared. Then I actually have to account for all of the other squares involved, because I know that there are 6 squares involved that have the exact same length. So guys, I hope that you're with me so far. So I've got a cube that's made of 6 squares. I take the area of each of the sides of the cube, and I have to add them all together because that will be the surface area of the entire cube. Because it is a cube, it's made up of squares, so that means that the lengths are common throughout. So I have L squared 6 times. Let's go back to the board. So this is going to be equal to 6L squared. So the total surface area of a cube can be calculated by taking 6 times L squared. Let's have a look at the next slide. Great, so the next definition is the surface area of a rectangular prism. The total surface area of a rectangular prism can be found by finding the sum of the areas of the different rectangles that make up the surface of the prism. So guys, this is kind of similar to a cube in a way, where we have 6 external faces that are making up the prism. If you look at the diagram, we have the left rectangle, the top rectangle, the back rectangle, the right rectangle, and the bottom rectangle. So we can see that we have 6 individual rectangles that comprise the area, or the surface area rather, of the prism, and I need to find the area of each of these to find the surface area. Please just note before I carry on that we have length, breadth, and height. The cube, it was all the same measurements, but for a rectangular prism, we have individual length, breadth, and height. If I'm going to be finding the surface area of the rectangular prism, I am going to first find the area of the top rectangle, the bottom rectangle, and we know that these are the same because it's a prism, it's almost like a box, the top and the bottom are the same. The front and the back triangle are the same, and the left and the right triangle are the same. So if I want to write what the surface area is equal to, it's going to be 2 times the area of the top triangle, which is the same as the bottom triangle. So it's going to be 2 times length times breadth, plus 2 times the area of the front and back rectangle, which are each length times height. And then I'm going to add 2 times the area of the left and right triangle, which are both height times base. And that is my formula for the surface area of a rectangular prism. Great, everyone. I hope that you are with me so far. After the break, we will look at some more practical examples of the surface area of a cube and rectangular prism. See you soon.